Hello. We try to solve another questions from your exercises. So this is question number 3-4. The diagram shows two forces acting on a body which rest on an inclined plane. Calculate the rectangular components of both forces parallel and perpendicular to the plane. So you have this body here, and there is a 20 newtons force trying to pull it up in that direction with 30 degrees inclined. And the other one is 10 newtons hanging vertical, which the other force we're trying to work out. So if we want to calculate the rectangular components of both forces, parallel and perpendicular to the plane, so we need first to resketch this question again. So I will use the same free body diagram. I will try to solve this question. So first of all, let's try to find the components of the 20 newtons. So first force will be going in that direction, and I'll write the equation for it. So let's say this one will be, because again, the force going towards the angle, which is 30 degrees. So it will be 20 cosine 30, and make sure to insert the degree sample. And if you have your own calculator, that will be 20 cosine 30. Make sure to set up your calculator to degrees. The answer will be 17.3 newtons. So 17.3 newtons. That's the first answer. Now, at the same time, if this is the horizontal components of the 20 newtons, now we can find the vertical, which will be going in that direction. So this force will be about that distance. I'll use again the blue. And if we try to find the value for this one, definitely will be 20 sine, again, the angle is 30. Remember, when we're going far away from the angle, so I use sine. And always remember to add the angle in degrees. And if you use your calculator, you can find the answer for this one is 20 sine 30 degrees is equal to 10 newtons. So that's the answer for this part of the force. I will just highlight this one, which is good. Now you will see what I'm doing as well. How can I type equations using PowerPoint slides? So we have done the first components, the horizontal and vertical, which are inclined in that direction. Now, what I need to do is to determine as well the components for the 10 newtons. So if I start with the vertical, which is going this, and if you look carefully, this line should be parallel to this one. So I'll use the green color for it, and then I'll try to determine the value for it. Now, before we determine the value for it, we need to remember that this angle, by replacement with the 25 degrees, will be equal to 25 degrees. And again, I will just insert the sample for that. So this tiny angle, it's equal to 25 degrees, this here. Therefore, to write or to find this force in that direction will be 10 newtons, and that's because it's going towards the angle, so it will be in a way will be cosine 25, and make sure to add the symbol for the degree. And if you try to solve that using your calculator, so 10 cosine 25 degrees will be 9.06 newtons. So that's the answer for this force. Now, if we try to close that, therefore, we'll have another component is going in on the horizontal direction, which is going in that way. So that component should be parallel to this one. So I'm trying to make it a bit looks parallel, and then I will use the green color to write it down. So the magnitude for this force will be 10 sine, and the angle again is 25 degrees. Now again, remember, Why we're using? Because if we're moving from this 10 newtons going in that direction far away from the 25 degrees, therefore I will use sine. So that will be equal, if you use your calculator, 10 sine 25 degrees will be 4.23 newtons. So this is the answer for this force. I would just make it look better. So by this, we managed to determine or calculate the rectangular components of both forces, parallel and perpendicular. Now it needs just to define each one of them. So if we want to say, how can we find the parallel forces? So we start with the parallel components. So we write an equations on the other side here. So we say parallel to the plane which will be, you have two forces. One is 17.3 newtons, and the other one, and the 4.23 newtons. And I will highlight these forces in yellow so you can understand what are the parallel. So I will highlight this in yellow so you know what we're talking about. And that's the other one, which is also the parallel forces. Now, if you try to find the perpendicular to the plane, so we need to again highlight these forces. So using the same thing we've done. So you have how many forces in the perpendicular direction? So you have the first one is the 10 newtons. So that's 10 newtons. And the other one, which is the 9.06 newtons. So I'll highlight this in different color. Let's say we'll highlight them in green, and I will indicate for you here, these are representing for me. So for example, this one represent for me the perpendicular, and the other one here perpendicular. Please take into consideration that one is moving or going upwards, pulling upwards, the other one is pulling downwards. So they have different directions. The same thing here for this, the parallel to the plane. So one is taking it up, and the other one is trying to drag it down. So that's one of the things you need to distinguish between them. Now, one thing you may ask me, how did you determine the angle of transferring this 25 degrees to that side? So let's draw a triangular, and we understand this one. So I will have, for example, this line, and between it another line will represent for me the angle, and we're trying to determine, and let's say till here, and then we try to determine the other angle in that direction, and we extend that. So, and then there is another one which is perpendicular here, which will give me the angle 90. So if we just take that angle, let's put the correct angle here. So this one we say is 25 degrees. Let's put the angle here. So that will be degrees. And I will just place it and move it here. And remember, this one, the tiny this angle is actually represent 90 degree. So I would just sketch to represent that this one is 90. So if this is 90 and this is 25, what do you expect to be this one? So what do you have? Let's write it down. So if it's the total angle here, you will have it. You should have something to represent for you what's the difference. So if this is a 180, let's write this down so we can understand the angle for this one. So 180 minus 25 minus 90 degrees, the answer will be equal to, so I will use my calculator to make sure I'm getting the right answer. So 180 minus 90 minus 25. So that will be equal to 65 degrees. So that angle will represent for me in that direction. So I will put this angle very clearly here. So this one represent for me 65, and if I go and put degrees, all right, just make sure. So if this is 65, then how can we determine that small tiny angle? Definitely that will be 90 degrees minus 65, and then will be equal to 25. So I will write for this one. First we need to put some kind of samples to show you where we moved from which one. So from this we move to this equation, and now to write the other one, so I'll open another box here, and then I'll write 90 degrees minus which is 65 will be equal to 25 degrees. So 25 degrees. So that's the angle which we can represent it in that position. So this, if I use the same method how we try to locate this angle, so this angle it's calculated by that. So that's how we determine this angle. Now, if I want to put the components for this force, therefore, if that was the inclined, therefore that's if we represent it in that way, so technically what we're trying to say, from here to there represents for me the force which was equal to 10 newtons. And let's put that's 10 newtons. Now, that's the 10 newtons. And if we use that angle, that's where it's giving me the components for the 10 newtons in that direction, which I will use the green to represent what we were doing earlier, and that will be equal to the value, as we say earlier, 10 cosine 25, which is equal 9.06, and the other one will be going in that other direction. So technically that's what we determined earlier in these equations to find how we transfer the 25 degrees from that position to that position. That's how we explain it here. So just simple to you, so you can really link these two together so you can understand what we were doing in between them. So that's technically what we were doing, is just too simple to you here. That's where it's coming from. All right, so let's just summarize this video again and see what we have done in this question. So the diagram shows two forces acting on a body which rests on an inclined plane. This is very important, that this plane is inclined with 25 degrees. Calculate the rectangular components of both forces parallel and perpendicular to the plane. So first of all, we have the 20 newtons. What we did analysis this to be 20 cosine 30. We did calculate it to be 17.3, and this is the horizontal force. And as well, we did calculate horizontal to the incline, by the way. And then we did calculate the 20 sine 30 degrees, which is perpendicular on the inclined body at that point. And then the same thing we did by transferring the angle from 25 degrees here to that position, as explained in this diagram. We managed to find the components of the vertical 10 cosine 25, or perpendicular to the plane, which is equal 9.06 newtons. And the other one, which is parallel to the plane, which is 10 sine 25, which is equal 4.23 newtons. And then that's the final answer for this question. I hope you guys enjoyed this video, and hopefully the quality of this video is better than the previous three. So from the future, I'll try to record more videos using this quality. Thanks again, and hopefully to see you in class. See ya.